textbook. And so if you will grab your textbook, because we're going to actually work through some of these and we look at in depth. I didn't create a ton of slides. What I want to do is just kind of go through the textbook and we're going to work at some of these programs and some of the coding directly. And unfortunately, this is really that class where it's horrible and it's evil because you have to go through and do this. If you don't work the code examples, you're not going to be able to do the programs. If you don't put the time and effort in, and it's not a huge effort and it's not a huge time commitment, it's not like you're going to spend 70 hours a week, but you are going to have to do that so you get that muscle memory and that skills up. So one of the things this week, just to remind you, before we disappear for a week, is we do have a discussion board this week. And so make sure you've posted for week 7 and week 8. Several of you haven't posted on week 7. Make sure you post on week 8. So I'm just asking the question of making you go out and look at other programming languages. I chose one. I have a lot of reasons for choosing it. It's very close to English language. It looks very much like the pseudocode that you're going to see in other places. The syntax is a little easier to wrap your head around, I think. It's free. We can get this one for free. But are there better languages we could have used? So that's the question I'm asking you for that. So you do have to do a little research and defend your particular answer. And then we have a problem in the class. So in this case, you're going to write a program. We're going to work with car salesmen. We're trying to figure out a final price. So it's going to take a little bit of those skills you've already developed, those algorithms, and now we're going to actually put it into the practice of Python. So you should have read Chapter 1 all about Python, and Chapter 1 was all of about 7 or 8, 10 pages. We need to make sure that we know the difference between the different modes in Python. And we're going to start looking at Chapter 2. And so I'm on whatever page Chapter 2 starts on, 15. So one of the things we need to talk about are the different types of variables. What kind of variables do we have in Python? We need to look at how do we use those variables. And so we already did a real quick example of putting in a name in a variable, but are there other things we can do with variables? What kind of syntax do we normally run? So if I flip over the page, there is a program on page 16 that we're going to start looking at, and we're going to start looking at creating a nearly useless trivia game. So if I look on page 17, and sometimes the easiest way is actually by putting our fingers onto the coding, and so I'm actually going to look at page 17, and we're going to recreate parts of this program. The game over in the ASCII text, I am probably not going to recreate because I don't want to type that, but something very similar. You'll also find that all of these code examples, you can find a ton of those out there. So the thing we're going to start is I'm going to bring up idle, and not Billy Idol, but I need this shell. And the first thing I'm almost always going to do is I'm not going to run anything from this shell itself. I'm always going to use that script mode. So I'm going to create a new file. And so we want a couple of pieces in here. One, I need to figure out where I'm going to save all of my files. And so I'm actually going to open up, where is a good place to put this? So I'm going to do Control E, and I'm going to open up my File Explorer. And I'm going to find the place that I am going to store them. If you're in class here, you may want to store them on a flash drive. On your own computer, you may want to store them in My Documents. And I'm actually going to open up Documents, and I'm going to create a new folder. And I'm going to call it Python. Or Python if I can't spell. And I'm going to store my programs as I work on them in here. So I know where they're at. And so now I've got a place that I've got set up that I can store my programs. So I'm going to create, the first thing I'm going to do is I'm going to create myself a template file. And so I'm in idle, going to create a template file, and I'm going to do a couple of things. Those comments, so if I put the pound sign in, that's not going to show up anywhere. So it's great for me to use, and I can use those comments. And I'm going to call this my template file. And I can put in a couple of other things. I might put in my name. That way I have it in every file I create. I'm going to work with this file. The other piece I'm going to put in, because at the end of nearly every file, it's a handy idea to put in that input statement. And I'm going to put it in like this. So input. And I'm literally just copying some of our text here. So I'm going to put a quote mark /n/n. And that just moves down spaces. Even though it's inside there, the program recognizes that /n is a new line. And then press Enter to exit. The purpose for this, so we have that ubiquitous end program. So I'm going to put a line above it. This line below holds open the program. And that's a key if I actually run this program directly. In this mode here, when I run it, it will stay open and I can see what's happened. If I actually run the program itself, and I'll show you here in just a second what I mean by that, we won't know that anything ever happened. So I'm going to click File, and now I'm going to click Save As. And so I'm going to call this my template file, and I'm going to go to Documents where I created that Python folder, and I'm going to call this one my template. And so now, every time I want to start a Python program, I can open up this template, and I have a place to begin. And so now I'm going to save it with a new name, because I don't want to wipe out that template. So let me just show you what I would mean by that. I'm going to start out. I'm going to go to my Internet Explorer or on your Mac, whatever you want to grab. I'm going to go to Documents, Python, and now if I click Edit with Idle, I can open that back up. Because I don't want to change that template, I want to then do a file save as. And in this case, maybe we would call it, maybe we'd call this one Game Over that we're going to work on. I save it. We really shouldn't have spaces, but they cause less problems than they used to. But now I have this program called Game Over. And if I look in here, I have two programs. I'm going to close that mode. Well, on top of being able to run this program from the script, I can actually just double-click on it. And it opens and it runs inside of a black text window. It'll actually run without having to have idle open. Just by clicking on it, it opens up an environment. But if, let me edit this really quickly and I will show you what happens. So if I don't have this line, and I can always do this as a test, I can put that pound sign in and get rid of any line I want to test. And I'm going to take that out of there. Now I'm going to save it again. If I now just double click and run it, what you can't see, because it of course pops up in the other window to make life miserable, it pops up that text window and closes immediately. We don't have any idea if the program ran correctly. It closes immediately. And so that's the purpose of having that input here at the bottom, is it holds this program open, whether I had a single print statement in there. So now I save that. And I run it. And it sets over here and it doesn't exit. It won't exit until I hit the enter key, and when I do, boom, the program goes away. So that input statement, just waiting for something, is a critical step. It holds that open so we can see the content of what we just created. So that's what my template would look like to start with. So very quickly we run into a couple of issues with some print statements even. So if I want to print, and so I'm looking at the content that should show up over here on the top of page 17. So we're going to have all of this. It says program game over 2.0. Game message as before, just a bit bigger, and then it has the ASCII art where it says game over. Well, when I do that, I'm like, oh, wow, I could do that first line. And so I want to try that. I'm going to say, all right, I'm going to print, because we know our print, we put everything we're going to print inside of those parentheses. And then we know that I want to put in program, but notice I can't just put another quote mark, and I can try it and see what happens. So I tried it with just another double quote, and notice what happens. My line in here, my line doesn't stay the green color. I'm like, wow, that's interesting. So let's see what happens if we actually run this. So before we can run anything, we have to save it. And I can click over here and click run. Or if I remember my shortcut key, I can hit that F5. And the first thing it's going to pop up is, oh, invalid syntax. And notice it's even highlighting it here for me, and it says, yeah, you screwed up. So if I want to show a quote mark, what I have to do is use my single quote inside of the double quote. And now look at that. At the difference there. So once I'm inside of the double quotes, I can use a single quote inside of there. And then I can hit F5 and I can run it. And notice it actually shows game over 2.0. All right, well that's kind of a cool thing. So we know we can figure out a way to put in those. And we have a lot of those. We'll look at the ASCII art here in just a little second. But we also want to be able to print multiple statements inside of one print. So I'm going to come back to my text. And I want to be able to print a couple of things inside of there. So let's do a little bit of testing. And so I'm going to do a print statement. And I'm going to put multiple statements inside of there. This is a test. And notice I hit a comma. So I closed my quote. I hit a comma. And now I'm going to put in another piece of text. of the emergency broadcast So I have 3 pieces in there. And so let's take a look at what's going to print. So I'm going to save it. And again, that experimenting, you don't have to do exactly what the book does either. You can experiment and try things and see what happens. So now I hit my F5. Yes, I'm going to save it. And I have some kind of invalid syntax, which is certainly possible. Oh, I didn't close. There we go. So close, comma. So. And I will tell you, if you haven't seen this screen up here, trying to see this thing is kind of a test of your eyesight. Because we're pushing out a different resolution to the projector than what the monitor will handle. So notice what it did. It put them together. This is a test of the emergency broadcast network. So even though I put them in separate pieces, it put them back together for me. And where I have broadcast and network, notice it even added a space for me. Python is really very accommodating. So I can even try another model. And let's see what happens. So I'm going to put a print up. And I'm going to put in just, because I'm going to follow the book on this one a little bit. And then I'm going to hit comma, and I'm going to hit the next line down. A little bit bigger. And I'm going to close that. So now I put my text actually on 3 lines. So you would think when it prints out, it's going to print on 3 lines, right? Are we going to get 3 lines of print? No, we haven't actually put a new line in, and we can test that then. And we can say, all right, we're going to save it, and then we can run it. And notice, yep, it did put it all together on 1 line. So we can use that white space. So we could make that easier to read there. But what if I put inside of one of these that slash above the enter key and an N? And let's see what happens then. So again, we're going to experiment a little bit. And notice when I put that slash in, notice what it did. It actually moved it down to a new line. So that slash in is how we're going to start new lines really, really easily. So if you want to work along and look at it, I'm working on page 18 and 19. Printing multiple values. So what it also does is each print line, we don't see it in there, but by default it throws in that new line character after the end of each print line. All right, so ASCII art used to be a really cool thing. Before we had graphics on our computers, back in the 70s and the earlier, the really nerdy people got really good at what's called ASCII art. And so if you look on the bottom of page 20, that's an idea of that ASCII art. In other words, they're using the different symbols to create something that says game over. So they're using pipe commands and all different kinds of things. So we can do something similar. And one of the keys to doing any of this kind of artwork, and in fact to format a lot of our text, is the idea of triple quoted strings. So if I flip to the next page and flip to page 22, you can see they show you how some of that works. But the triple quoted string, so if I do a print and I put in 3 quote marks, that's a special character. Notice everything below it now even my comments and everything have now become a text item. And I don't see that, notice, with just one. So by the time I do that third one, it tells that there's something special in there. And I do 3 to end it. Anything inside of here is going to get printed. Of triple quoted text. So I'm going to save this one really quickly. Oh, it would be helpful if I did one more line. And I actually closed that. All right, so notice everything inside there, I didn't have to put in the line characters. It just grabs everything and says, oh yeah, let me just take that. And so this is a really great way to get some formatted text if I need to do that. So we have some other funky special commands we can use. So on page 22, we look at tab stops. So we have tab stops. So just like we had those in marks, I can come in here and put in tab stops. So maybe this is a test /t. And that slash tells the Python that, hey, there's a special character going to go there. And so now if I ran this, it's going to change my line up here. And notice it tabbed that out. And so we can create tabs that way really easily. So tabs and new lines, it's kind of weird. They go right into your text, and the program ignores them. So if I really need to show a quote mark, page 23 says, all right, we can do that. We can show a quote mark, but we have to use, a lot of times we call them escape characters. So to kind of get an idea about what an escape character is, we need to know about how the world works in the world of our computer. So let me bring this over. So inside of our computer, it only works with zeros and ones. And so there has to be some way to convert from zeros and ones to text. And the original method is something called ASCII. And so if you'll notice, all of the pieces we want, so decimal over here, 0 through 32, we have all these different characters. I get to 20, for example, and that's our escape character in most cases. And you'll see that we start having numbers here. We start having letters here. And notice that capitals have their own separate grouping. So capital letters, lowercase letters. And in fact, if we look down below, you'll see we have all the way to 255. And so those of you that had to suffer through me talking about binary and other classes, this is an example of what 1 byte, B-Y-T-E, can contain. Any of these characters. And so that is where we end up with this. So if I want to put any of these characters in, I can look up a chart, and I can actually put in that character specifically that value. So let me move this out of the way temporarily. So I can put in a character specifically by its number if I really want to. So any of those characters I can put in, and some of them have some special meanings. So if I look at the bottom of page 23, I can do something called a bell even. So originally, computers didn't have sound. We didn't have all these fun things. The only thing we had was a was a bell character, a ding. And so it would alert us that something was going on. Well, I can use that, and I can put that inside of a print statement. And I can actually cause it to make a sound. And I don't know if it will on this particular one, but we'll try to find out. So F5, I'm going to save this. And when I run it, I don't hear a sound on this particular computer. But I'm also trying to record in here, so it may be the case. On your own computer, you can try it. It will probably make some kind of obnoxious dinging noise that you can actually hear. I'm going to guess I have it muted so that it's not going to do that. So we can do any of those kinds of characters that we want. And so on the top of page 22, they look at the tab characters and how you can arrange things. They put the bell in there. We have a lot of different pieces we can do. So if you look at page 24 and we look at those listings, there's tables in here. And I tend to highlight those because those tables have a lot of information as we go forward. So in this case, we can see that the // will print a backslash on our screen for us, that we can put a / quote mark so it says, yep, we know we need a quote. So it's telling us that it's different than our normal text. So we can do all these kinds of things. And I encourage you to work through this. The code is actually here to create that ASCII code, but we don't have time in class to do that, to create that ASCII code. It's kind of interesting to do it because you can see the different characters on your screen. So the piping characters and the different pieces. So you can actually print any of those ASCII characters that you see in here. So again, this is just a handy, quick way. I just looked it up. You have all these special characters. Some of them used to do some things and they don't anymore, but there's 256 different characters we can print out and show what that is. So I'm going to save this one now because I'm kind of done with it for now. So I should have called this game over. I didn't. I didn't ever change that. So I'm just going to start out with my template file. So I have up here a couple of things that say what I'm doing. That line below. Well, this time I am going to change the name of it, and I'm going to change it to Silly Strings. So I know what it does. So a string in our world, and I'm going to then do a file, save as. So a string in our world is nothing more than a set of characters. And we can do some interesting things then with those characters. Because our program and our language doesn't know what to do with them other than it says, you have something in this symbol of text. It doesn't mean anything to me yet. And so the first thing we need to do is we need to learn about a new term called concatenate. And concatenate really just means put together. And so the first thing we're going to do is we're going to put two strings together and we're going to concatenate them together. And so I'm going to start with my print statement. You can concatenate two. Now, just like we do a math operation, we're going to put a plus symbol in there. So we're adding this string with the, and notice to show that operator, I've got to use a single quote So I've now put those together. And it creates a brand new string. So now if I run this, I saved it, and it put that line together with that plus symbol. So it said this string of characters plus this string is now going to be output into the world. So we're going to do a longer version of that concatenation. So if you will turn to page 26, in the middle of the page they have a print statement. And they have a really long print statement. And so we're going to take a piece of that. So it's actually, in this case, I think it's 22 or 23 different pieces altogether. We're not going to probably do all of that right now, but I encourage you to see if you can, and see if you can even run into a length limit on doing this. So this starts with a new line character, so it moves it down one. This string, space. And so one of the things I want to notice, when I do this concatenation, I have to put that space inside of my quote marks. If I don't, it really will run them just together. When I put the comma in, it was very nice, and it put that space in between words for me. When I concatenate them together, it doesn't do that. So, may not, space, seem terror. Now in this case, I'm not going to put a space in because I want this word, because notice we even broke up a word terribly, and then a plus sign, and then notice we put, I'm just going to end it here for now. So this line, when I print that, notice it put terribly back together again. And where that lets us do things then is we can construct alphabet programs. So if we want to add different endings to words, we can use that concatenation to do that. We also can do some other interesting things. So if we want to put multiple lines of text and put them together, even though they're written in different print lines, I can do that also. And so remember that normally, so it printed this on 2 lines. Normally, whenever I end a print line, it has that built-in new line at the end of it, essentially. It says whatever's going to print next is going to print on the next line. Well, we can put an end of line character in, and we can actually do something where it says, okay, I want it to not print on multiple lines. So we want that backslash line. We can put it in here. We can go, okay. And in theory, we can stop it from running. So you'll have to figure out how to do that. It's on the middle of page 26. So we're going to put in a line continuation character. So instead of putting on new lines, we joined it. So notice what we did here. On that long print statement where it puts in just a single So we end our print. We put our mark in and we put a plus sign. And then we can end our statement. So we can do that and actually run on multiple lines. So we can now start manipulating some of this text really, really easily. We can even do some interesting things where Python is really, really, really smart. Python will let us work and repeat things. We don't have to create a loop. If I do a print statement, I can actually do something really interesting. So I'm going to print, it's not quite Grilled Cheese Wednesday yet, but grilled cheeses for all and then I don't put a comma, I don't put a plus, I don't put any other symbol in other than I'm going to use the times character. And in this case, I'm going to put 25, and then I'm going to close my print. So there's a couple of pieces that happen in here. So it says, all right, here's a string that I'm going to print, and it says, oh, and you want me to print it 25 times. So now if I run this, notice it printed grilled cheese 25 times. But did it print it all on new lines? And if I wanted to do that, well, let me think what I can do. If I put in that new line character at the end of it, or I could do it at the beginning, quite frankly. Now I printed grilled cheeses for all 25 times. So there's some handy shortcuts inside of Python. So what it's really doing is just taking this grilled cheese, and it says I'm going to repeat this command 25 times. And I can do that with almost any string we work with. So Python has a lot of really quick and easy ways to manipulate our text. It's pretty smart. It tries to do what you tell it. We have to remember these print statements they're a function, and a function takes in an input. In this case, it takes in the input of this string, and it takes in the input of how many times. So it takes in all that input, processes, and then spits it back out on the screen for us. And if you want to see how fast Python can process on your own computer, do this for like 2,500 iterations, and you'll see that's how quick it just printed 2,500 lines up there. So you could expand it, and you could play with it and see, how do I start noticing that my computer is going to get slower? And so now when I did, I think 25,000, now it took a couple seconds for it to do that. So that's kind of the speed of a single line of Python code if you want to look at it that way. So in Python, we really have two basic kinds of characters we're going to use. So I'm going to delete this, and I'm going to open up my template again. And remember, I can just right-click and edit. I have a couple different versions of Idle Editor on here. So here's my template again. So Python has really two different things. We can work with strings of numbers, or we'll call them variables. Some languages call them varchars, variable characters, and different things. But for our purposes, we'll just call them strings. So strings are groups of things that are inside of quote marks. They could be text, they could be numbers, but we don't know if they're numbers or not yet. We think they're just all kinds of text objects. We can manipulate those, but we can also work with numbers. And so I can look at that and I can say, well, I want a print statement, and I want to print 10 times 20. And we can see if it's smart enough to figure that one out. And apparently it is, because I got a number there. And I can go, oh, all right, that's pretty impressive. Let me see if I can change that. Will it do 10 minus 20? I hope. Yep, it does that. And so my normal math functions are all available to me. And it certainly seems like it's working with a number of some sort. We can even try some higher functions. So we can do that. It didn't seem to work quite the way we thought it would, because 10 to the 20th power, if that symbol really worked, would be more than 20. So it must use that as a plus symbol. So we have some weird quirks we have to find. But we can work with all kinds of numbers. So we have to make sure we differentiate between these different types of numbers and these different types of numbers. So on page 29, there is a list of the math operations that we commonly do. So we want to look at a couple of them because they may be different than what you're used to. So the first one, the plus and the minus, well, we're pretty used to that. We can do those pretty easily, plus, minus. But we also have a couple that are different. So multiplication is our asterisk key, not horrible there. But we have two divisions. And so if I have 5 divided by 3, and I have, our print's an easy way to just tell us what's going on. 5, and I put 2 division signs in there. It says that's an integer division. And so now I can run this, and I can see the difference right away, what's going to happen. So if I divide 5 by 3, I get 1.66666666 until it finally rounds up. It runs out of digits. Okay, that makes sense to me in my brain, because if I divided that on my calculator, that's what I'm going to get. But a lot of times we really want to work with integers. And so integers give us that whole number. And so if I do a double division line here, I get the value of 1. It just strips off all of this and says, all right, there's my 1. In a lot of cases, though, what's actually interesting to us, weirdly, is actually this portion here called the remainder, if you want to think about it. Or in this case, we're going to call it the modulus. And so that modulus operator, so if I do the same thing here, watch what happens here. So print 5 modulus 3. And now I run that. Now I get the remainder. So this divided it all out. This says, here's my integer result, because I know I can only take 1, 3 out of 5. And this says, here's the remainder, that remainder 2. So we can get all those pieces. And so we actually find we use that modulus operator a lot when we do that. And so we can print all kinds of things. So if I wanted to print that value, though, so let me put this in, print 5 divided by 3 so I can put that in a text and then a comma, and then I could do 5 divided by 3. So I could quickly show what I'm doing. So here, 5 divided by 3 equals 1.666. Guess it'd be helpful if I actually put the equal sign in there. And so I could put that in there to explain what that is. I could explain then that integer division and that would give me that same result. And so I can edit my text so it shows really nicely what I'm doing. Integer division, 5 divided by 3 equals 1. We don't show that remainder or that decimal fraction. And it literally just cuts it off. It doesn't matter how close I get, it's always going to just round down essentially by chopping off that remainder. So we can manipulate things with math the same way we can manipulate strings. What I can't do is do them interchangeably. So print 5 divided by 5. So the string value of 5, and we'll see what happens when I try to run this. It's going to say, oh my gosh, there's a, nope, that's not going to work. And the problem is we're trying to take a string and we're going to divide it into a number. And we can't do that directly. So we're going to have to figure out some ways to manipulate numbers a little differently. But part of that then is working with our friend, the variable. And so some of us have already played around with the variable when we created our hello program. And here's what the really neat thing about Python, or the really aggravating thing, depending on how you look at it. Most programming languages require you to declare your variables all up in one sentence or one statement up top, and you have to declare it as a type. So you'd have something like, and I'm going to get rid of all this, you'd have something about, I'm going to declare a numeric variable named Mark. So that variable would be named Mark. It would have a numeric type. And in fact, in some of them, we might have to call it an integer, or we might have to call it a decimal or a long decimal, and all these different things. Well, Python says, you know what, you don't need to do any of that. I'll handle the variables for you. You just kind of have to keep track of them. And all I have to do is say Mark equals 25, and I've created a variable. So Python lets us do things really, really easily. Depending on what other language we're going to use, this is either a good thing or a bad thing. So if I said, maybe I use this one, so I'm going to use name as a variable. And you could put in your own name. My name is Mark Zuckerberg, spelled wrong. That way I don't get in trouble with the Facebook police. So then I could just do a print of name, and I could even do the, times 10 if I wanted to. And notice it printed out Mark Zuckerberg, Zuckerberg, Zuckerberg 10 times. So it took that value and assigned it to name, and we printed it out 10 times. And I could put in the escape sequence, or I could do that to print new lines. Well, those variables are really, really easy to use. What I would like to do is make sure we're all on kind of the same naming convention. So variables, for our purposes, always going to be lowercase, the first name. If I use a couple of pieces, so if I change this variable to last name, we're going to use what's called camel casing. So that last name, there's no spaces, because spaces are going to give us problems. So if you try to put last name, it's not going to know what that variable is. So can't have any spaces, and we capitalize the second letter of the second word in there to put it together. So last name equals Mark Zuckerberg. And now I'm going to run this program again. And it's going to tell me that it's not defined because I defined last name, not name here. So I would have to go last name. And I'm going to run it again just to see what happens. And why is it not defined? I put it as last name, but notice that capital, last name, they have to be the same. So one of the tips I usually do is once I create my variables, I'll tend to cut and paste them just to make sure they're the same. I want descriptive variables. And so why isn't last name with a lowercase and last name with an uppercase the same? Well, that has to do if I come back over to my ASCII chart. And if I look at this, that's interpreting, this is my capital N, this is my lowercase n. They're two different variables. And in fact, later on, it's going to present some challenges for us, because if I want to alphabetize something, the alphabetical, when I try to sort them, capital N and lowercase n are different. And so we're going to have to figure out a workaround for that. So we can create variables. We just did. We created one called last name, so we probably should take out the mark piece if we're going to do that. And we can do a print statement with it there. So last name. Got to make sure they're the same. If it's not, you will run into this issue. That's the one of them that I see more often than any other problem that we run into. So, what I like, so if you look on page 32, there's a list of some rules for Python and some kind of really descriptive things. So, variable name can only contain letters, numbers, and underscores. Well, underscores are okay, and some people prefer that. I think it's easier to use camel casing. What I especially don't want to see is if you're using both of them in the same code, be descriptive. You want to be some kind of a descriptive name so that when I look at your code, I understand what you're doing and you can remember what you're doing. Last name is different than X. We could use X, so I could change this, and the computer doesn't care. In fact, the computer, quite frankly, prefers nice short little names. But X, while it runs, doesn't tell us when I look at this code what that's supposed to represent. So we want to use descriptive variable names, and we want it to be consistent. So the author here, weirdly, uses the underscores. I like the camel casing, just a difference of opinion. And there are some languages that have different features or different characteristics. So Python always likes to use a lowercase letter. Where we use uppercase tends to be, say, this is a constant. We're not going to change it at any point. And while we want to be descriptive, you also have some length limits. You can actually put in a variable 255 characters long. Don't do that. Descriptive, couple of words in our programs are long enough. So the bottom there in the little where it says trick, it's talking about using self-documenting code. And that idea is we can look at it. We don't have to have as many of these code segments here where it says colon this. So I don't have to necessarily put it the X above there. The X is for last names. Now, it's not a bad idea to put in as many comments as you want so you can tell me what you're doing. But if we use some self-documenting code, it's already in there. It's already in there for us. So we're going to do one more thing, and then we're going to get out of here for today. and that is we're going to introduce you to an input statement. So input statements are one of those that have changed significantly from versions to versions. So the 2.7 version and the 3x versions that we're using are very, very different in Python. And so if you start to see me type something called raw input, that means that I suddenly flashed back to 5 or 6 years ago and started writing in 2.7. But the input is just another function built into Python. And so we could do this. So let's use our variable name, and we're gonna put some kind of value in it. That equal sign is really saying I'm going to put whatever's to the right of me into that variable. And so I'm going to use our friend the input. And notice it changes color. It's a function, so I know I have to put my parentheses up. But it also lets me embed directly in here some text. Hi, what is your name? Now, I always put a space in there because you'll see why here in a second. And then I have to close it. So this is going to say, hi, what's your name? And in theory, it's going to put it back into the variable input. So Python saves us a couple steps from most languages. Most languages, we'd have to have a print statement of some sort that says, hey, what's your name? And then the input statement. So we'd have to declare a variable, print some text, and then actually get an input. And we're doing it all in one step in Python. So whether that's good or bad, well, we'll find out. So I'm going to hit F5, save it, and it says, hi, what is your name? And notice I type at the end of that line. So when I type at the end of that line, if I didn't have put that space, or if I had not put that space in there, it would be right on top of that question mark. So now I've typed that in and I hit enter. Well, now the program runs. It didn't do anything with that variable. It took it in. Well, let's make sure that it really is in there like we think it is. So we're going to put a print statement. Hi. Name, comma, welcome to the brand new hotel at Peru. So now, if I do this right, it's going to take my name. So my name just became John. And it says, hi, John, welcome to the brand new hotel at Peru. So it took our name, and it created a greeting back to us based on our name. So that input function, and we talk a lot about it on page 34, so we've used it before. You've seen it down here. And this just holds the program open. This time now, we're actually getting an input, and we're assigning it a value. So we can grab these inputs, and we can do a lot of things with them. And so starting on Thursday, we're going to show you how to manipulate those and set up some of the ideas of what you might do for your homework assignment due this week. So just as a quick reminder, we don't have class next week. Yay. And then so we return. So you'll see the due dates on there reflect that for week 9. So week 8 ends, and then we don't have a week in there. So there we hide a week in there. So, all right. So if you haven't got your book, get your book now. Use your book. This is your lifeline. Everything in here we need to work through for you to be able to kind of become conversant then in Python. You have to be able to save and look at those, so find a spot. If you're moving around place to place, put it on a little flash drive. They're cheap and easy. If you're at Walmart, you can get a small one for a couple of bucks. Make sure when you save your file, so I'm going to go ahead and close my script piece. Make sure that you save these to the appropriate file name and you know where they're at, because in the future, what you're going to turn in are these .py files. So you're going to turn in a file like game over or silly strings or whatever it is we're having you create. In this case, I think it's car salesman or something you would create. So make sure you have those so you can turn those in